Hello class, this is a video tutorial on the series problems, part 1. In this one we'll be focusing on arithmetic series problems. By summarizing the information from the question, we can more easily understand what to work towards. So when it comes to these sorts of questions, they can vary drastically, so it's impossible to cover every single type. But here are 2 types of examples. But focus more on the method and the thinking that goes into how we do this. So here we go. You can pause the video and try these 2 questions yourselves, but I'm going to be going at the pace I normally would in an exam condition. So here we go. First thing I notice, it says that the sum of the first 11 terms of a series is 473. I remember that the sum of the series, of an arithmetic series, S of n is equal to n over 2a plus d, n minus 1. So now it says the first 11 terms, so S of 11 is equal to 11 over 2a plus d of n minus 1. And it says that the sum of this is 473. So 473. I'm going to simplify this as best I can. I'm going to multiply both sides by 2. So we get 11 outside of 2a plus d. Oh, sorry. Also, I just realized this n should have been 11 take away 1, because remember it's the 11th term, so we can actually use that. That should have been 11 take away 1, so this is 10d. 473 times 2, and you know what, I'll divide by the 11 as well, so 473 times 2, it's 946. And if we divide 11, do we get a nice number? Let's test it here. 86. Okay, so I'm going to have this expression, 2a plus 10d equals 86. Let's actually keep simplifying until we get a by itself. So I'm going to divide everything by 2. We get a plus 5d. Dividing this by 2, 43, I believe it is. And here we have one expression that we can work with in future. It now says that the 15th term of the series, of the same series, is 115. So the t of n, I hope we can remember, is a plus d n minus 1. It's now saying that the 15th term, so t 15, is equal to a plus d 15 take away 1, and it's equal to 115. Well, simplifying this, we get a plus 14d is equal to 115. So I hope you can see now we have 2 expressions that we now need to simultaneously solve. So let's write them on top of each other. We get a plus 14d is equal to 115. That's this one here. And the second one is a plus 5d is equal to 43. Now I hope you remember your methods of simultaneous equation. I'm going to do this using elimination. I'm going to subtract. So a take away a, that's going to be 0a, so it's gone, so 0a. 14 take away 5 is 9d. 115 take away 43. It's equal to 72. We can now find the common difference. Dividing both sides by 9, we get 8. So the common difference is 8, which now if we just substitute this into any of the formula that we have, so I'm just going to use, let's say this one. Actually, no, we'll use this one, it's easier. We get a plus 5 times 8, my apologies, is equal to 43. Well, 5 times 8 is 40, so a is equal to 3. So we're nearly done. It's now asking for the 23rd term. Well, using our t of n, we have now 3 plus, a common difference is 8, sorry. So 8, n minus 1. Well, to find the 23rd term, it's going to be 3 plus 8, 23, take away 1. Straight into a calculator for this. 3 plus 8, 23, take away 1. We get 179. So the 23rd term, is 179. And there we go. Now, that's just the first problem that we'll be seeing. Just a quick heads up, we're going to be doing a lot of simultaneous equations for this. So I hope you're ready to be doing a lot of those. So here's another example. You can go ahead and pause the video and give it a go. So it says now the 5th and 8th term of a series are negative 16 and negative 34 respectively. So it says t, so the 5th term is equal to negative 16, and the 8th term is negative 34. What it's asking for is t of n is going to be less than negative 200. So what value n will give me negative 200 or less? Well, we're now going to need to find some expression for t of n. So t of n is equal to a plus d n minus 1. But we now know the 5th term, so a plus d, 5 take away 1. This is the 5th term. That's equal to negative 16. So we get a plus 4d is equal to negative 16. And if we do the exact same idea for the 8th term, we get a plus d, 8 take away 1 is equal to negative 34. Well, we get a plus 7d is equal to negative 34. Using these two in our simultaneous equation, you can use whichever method you like. I'm going to be using elimination again. Just for you all so you can see substitution, I'm going to rearrange this first one into negative 16 take away 4d. I'm going to use this expression and substitute it here. This will give us negative 16 minus 4d, so here's that substitution into a, plus 7d is equal to negative 34. This will give us negative 16 plus 3d equals negative 34. Solving for d, we get 3d is equal to negative 34, negative plus 16, we get negative 18. The common difference is negative 6. And from this, we can find the first term. A equals negative 16 minus 4 times negative 6. I'm taking this one from this expression. So negative 16 minus 4 times negative 6. We get the first term being 8. So we now have an expression for A and D. Try to keep this as neat as possible. So we now have T of n. The first term was 8 plus, sorry, not plus, will be minus 6 n minus 1. Now we want the first term, 8, take away 6, n minus 1. We want this to be less than negative 200. Solving for n. So I'm just expanding this group. Negative 6 times n, negative 6n, negative 6 times negative 1 is plus 6. We get negative 6n plus 14 is less than negative 200. Negative 6n is less than negative 214. Dividing by negative 6, we flip the sign, the inequality. So 214, negative 214 divided by negative 6, we get 35.6 recurring. So any number greater than 35.6 will give us a number less than negative 200. But when it comes to series, we can't have terms in between. So because there is the 35th term and the 36th term, we can't have any in between. So the number greater than 35.6 must be the 36th term. So that answers this question here. So what term will first be less than negative 200? The 36th term. So I hope that gave you an insight into how we might apply what we know from the sum and the terms of an arithmetic series to solve given problems. Hope to see you in the next video. Best of luck.